This video is for Leaving Cert Ordinary Level 2015, Paper 1, Question 8. So the question starts off with a function for profit that we're being given, p equals 96x minus 0.03x squared. And we're being told that p represents profit in euro and x represents the number of barrels of oil traded in a day. And the first thing they want us to do is complete this table. So we can, if we like, just substitute each x value into our function and write our result for p into our table. Or if you prefer, you can do it all in one go on your calculator using the functions option, the table option, f of x equals. You can type in your full function if you like. So 96 alpha x minus 0.03, and that is x squared, so alpha x squared. Press equals to register it, equals again, and then I'm starting at 500 and I'm going up in 500s. So I'll start at 500 and I'll end at 2500 and I'm going to go up in steps of 500. And once I get that, I can see that I've got my full table represented on the calculator, and the first value on the calculator matches up with the first value that I've already been given in the table. So I can then fill those values in. So my daily profit goes 40,500, 66,000, 76,500, 70,000 and 52,500. Now we're being asked to draw the graph of this function. We're given the xy plane already laid out for us. So we just fill in the points. For example, 500 on the x-axis and 40,500 on the y-axis. Just note that as I fill in my first point, 500 is fine. 40,500, well, 40,000 is here and this is 45,000. So halfway between the two, I've got 42,500. So when I want to do 40,500, I'm only going to go part of the way between 40,000 and 42,500. It should be, if I was being really exact, 1/5 of the way, but it's not like I've got a whole load of space here in this. So as long as it's kind of roughly in the right area, you're fine. When I go to mark the next value in, I go out to 1,000. And again, I want to go up this time to 66,000. So just looking at my scale here on the left, 65,000, 70,000, halfway between the two of those is 67,500. I don't quite want to go as far as that. I'm going to go slightly less than halfway between 65,000 and 67,500 to get my 66,000. So just bear that in mind as you're marking in each of your points. My very last point is a nice one because it was 52,500, and that's exactly halfway between 50,000 and 55,000. And then I'll join these up to make my curve, and I can see it looks like it's a quadratic. So make sure to go through each point as you draw your graph and try and keep it nice and smooth as you're doing so. Now we want to use our graph to do a bit of estimation. So they're saying to estimate the daily profit when 1,700 barrels are traded. So the number of barrels of oil is on the horizontal axis, so I need to find 1,750, and that's exactly halfway between 1,500 and 2,000. So I'm going to go to this point on the x-axis here, and I'm going to draw a line from that up until I meet the graph and then over to the other axis. So on my graph, that's coming in just under 75,000. So remember again, this middle line is 72,500. So I'm probably at about 74,500 there. So this is my estimate from my graph. Now the actual exact right answer is 76,125, but everyone's graph is going to be a little bit different. You're going to get discrepancies between your value and the exact true value. That's not too much of a problem as long as you are reading it accurately from your own graph. Part 2, the number of barrels traded when daily profit is 60,000. So I need to go to 60,000 in this case on the profit axis. And then I'm going to just do a repeat of what I did just in reverse. I'm going to draw a line horizontally, and just be aware that you need to keep that line going right out until you're past all of your graph. And then at the locations where you meet your graph, just drop a line down to the x-axis and read your result. And my answers for this will be the positions that I land on the x-axis. So I'm going to just read those off now. Let's try and do our best with this. This is 500, this is 1,000. So this number between the two of them is 750. And this will be halfway between 750 and 1,000. So this grid line is 875. So I'm just short of that. So I'd say I'm around about maybe 830, 820. Again, estimate it as closely as you can. They will allow you a bit of leeway. Looking at my second position over here, I've got 2000, 2500. That means this is 2000, 2500 at this dash. And this grid line here is 2375, and I'm just before that. So I'd say a reasonable estimate there might be about 2350. To guarantee myself full marks in this, I should really watch out to see are there any units that I should include. So they're saying daily profit is what we're looking for in part 1. So the profit has been measured in euro, so I should include that in my solution here. And they're asking me for the number of barrels down here. So I can write in barrels if I like, but since they've already said in the question that it's in barrels, it's not completely essential. Okay, so in D part 1, they're saying use calculus to find the number of barrels traded will earn the maximum daily profit. So I'm going to start by writing down my profit function. So I want to earn maximum profit. So the equation for profit is 96x minus 0.03x squared. So don't forget your steps for maximum and minimum. You're going to differentiate and then let that equal to 0. So what should I call my derivative this time? Well, if my function was called y equals, I'd probably call it dy dx. This time it's called p equals. So a good name for it would be dp dx. And when I differentiate this, I'm going to get 96 minus 0.06x. Why is that again? Well, don't forget if I've got an x term, well, it's just an x at the end, I just drop the x and keep the coefficient. And if I've got a power, I bring the power in front and multiply. That's where I got the 0.06 from. And then I drop the power by 1. So now this must be that equal to 0. And I want to solve this equation for x. Okay, so it's just the usual here now. Get the coefficients one side, get the x's the other side, and solve. So I'm just bringing my x term over to the right and making it positive. And then I'll bring my 0.06 across and divide it into 96. And in this case, I get a result of 1,600. Now, if you look back to your diagram, you'll see that when you go to 1,600 barrels of oil and you go up, it does look like you're at the top of your function. So we're pretty sure that this does give us maximum. But if you want to be absolutely bulletproof, just do your second derivative and check using that. So I look at my dp dx equation and I differentiate it, and I'm going to get minus 0.06. And I don't even need to fill anything into this because there's no x's left, but I just need to observe that I'm after getting a negative result. And of course, a negative result automatically means I'm at a maximum point. And it's nice to just conclude this then by saying how many barrels of oil we're talking about. So I can state that I'll get a max profit at 1,600 barrels of oil. They then want us in part 2 to go on and find this max profit. Well, don't forget, this P equation that we saw at the start of D part 1, that's just our profit equation. And the X stands for the number of barrels. So if I know that 1,600 barrels is going to give me my maximum profit, I can find that max profit by putting this value in for X. And it comes out at 76,800. We're told in part E that the trader won't make a profit if he goes over a certain number of barrels of oil in a day. And we're calling that value K, and we want to find the value of that number K. So to figure out what they actually mean by this in the question, it's worth our while going back to look at our diagram again for a moment. So we can see in our diagram that this vertical axis represents our profit. And as I move along my curve, my function, I'm getting closer and closer to 0, if you like. He's kind of getting diminishing returns. He starts off, he's making loads of money, and then he hits a certain value and it starts to drop off. And at a certain stage, he's not going to make any more profit. Now, we don't quite see this in our diagram, but we can extend our curve to show it. So what's going to happen is eventually he's going to dip down below the x-axis. And of course, the x-axis represents 0 in terms of profit. So I just want to know, when's this going to happen? So really what I'm looking for in this case is I'm looking for the root of my quadratic. So what I want to try and do is factorize the function that goes with this. I'll get 2 solutions. One of them will represent a value back here, but I'm not bothered about that. I want to know at what stage later on, what value does he have to go over in order to hit 0 profit. So I'm going to want this route over here. So let's go back to part E again. So we've got our profit, and that's P equals 96x minus 0.03x squared. And we want this profit to be 0 because he's not going to make any profit. And now I want to factorize and solve this. And actually that's nice enough to do in this case, because if you look at it, you can see that both of these terms have an x in them. So all I really have to do to factorize is just factorize out that x. So when I factorize that out then, I'm going to let both of my factors equal to 0. Now my first factor is at x, so x equals 0, and 96 minus 0.03x equals 0. And then, well, I don't need to solve this, it's already solved for me, I just need to solve this one over here. So to work out the x value, I'll just divide 96 by 0.03. And I get 3,200. And again, just to refer back to our diagram for a second, that looks like it's probably right, doesn't it? So 3,200 is somewhere over here. So that's the value they're talking about in the question. So to finish up, I'm just going to call that value 3,200 by its right name, and I'll stick in the units. So they want K barrels of oil, calculate the value of K. So I'll just say K equals 3,200, and it's 3,200 barrels.